Welcome back to Teacher Gimble's channel. Today we'll be going over Illustrative Math, Algebra 2, Unit 1, Lesson 7 practice. If you like this video, make sure to like and subscribe by pressing the button over there, and so you can see more videos like this. Let's go. We're going to start with problem 1. Problem 1. Here's a recursive definition of a sequence. So our first term is equal to 10. Every subsequent term is going to be equal to the term before it minus 1.5 for any term that's 2 or greater. Now, if you need to go over what this notation is, in the past 2 videos, I described it in a lot of detail, so make sure to go back if you're not comfortable with this notation, because it is so important that you understand this notation in order to understand these videos with this concept. So let's look. Is the sequence geometric, arithmetic, or neither? We are subtracting a constant from each term, so it is arithmetic. List at least the first 5 terms of the sequence. Well, the first term is 10. Each next term is going to be the one before it minus 1.5. So the next term, the one before it, is going to be 10. 10 minus 1.5 is 8.5. The one before this term is 8.5 minus 1.5 is 7.0. And we're going to go to 5.55 minus 1.5, and we are left at 4.0. Graph the values of the term f as a function of the term number n for at least the first 5 values of the sequence. So we are going to have a function. This is going to be terms. We're graphing 1, 2, 3, 4, 5. And we raised for 10, so let's do 2, 4, 6, 8, 10. The first term is 10. The second term is 8.5. The next term is 7. The next term is 5.5. And then the next term down there is 4.0. This 5.5 should be closer to there. It's a line, and that's how we know it's arithmetic. Arithmetic sequences always make a linear function when we're graphed, or a line. Let's go on to question number 2. An arithmetic sequence starts 12, 6. Write a recursive definition for the sequence. Graph at least the first 5 terms for the sequence. Okay, well, we know our first term of the sequence is going to be a of 1 is equal to 12. We know it is an arithmetic sequence, so it's going to be minus 6 from each time, because to get from 12 to 6 is minus 6. So our general function is going to be a to the n. It's going to be the previous term minus 6 will get us the term that we're looking for. Let's go ahead and figure out the first 5 terms of the sequence. Well, we have 12, 6, 0, negative 6, negative 12. And let's graph this. I'm going to graph this on an xy axis that has negative numbers because I know that my values go below 0. So I have 1, 2, 3, 4, 5. Those represent my terms that I'm using. And I'm going to do negative 5, negative 10, positive 5, positive 10. So my first term is 12. My next term is 6. My third term is 0. Then I go down to negative 6 and negative 10. And again, because this is an arithmetic sequence, our dots line up very well. Let's go on to the next question. An arithmetic sequence begins with 11, 7. Write a recursive definition for the sequence using function notation. Sketch a graph of the first 5 terms of a. Explain how to use a recursive definition for a to 100. Don't actually determine the value. So our first term is 11. So we are going to have a to the first 1 is 11 because 1 is our first term. And then every term after that is going to be the term before, which is what that stands for. And let's see if it's an arithmetic sequence. From 11 to 7, we subtracted 4. So it's going to be the term before minus 4. And to graph it, we are going to need the first 5 terms. So 11 to 7 is minus 4. Minus another 4 is 3. Minus another 4 is negative 1. Minus another 4 is negative 5. Now, if this feels unfamiliar, you should definitely go back to the last 2 videos because we go over how to do this in depth. It's going to be positive 5, positive 10, negative 5, negative 10. And I'm just sketching this. So when we're sketching, we don't need to be super specific with where we are putting our numbers as long as there are roughly equal intervals. So our first term is 11. He's going to go up there. Our next term is 7. He's going to go here. Then it's 3. Then we're going to negative 1. and then down to -5. It's an arithmetic sequence. They should line up in a line. Explain how to use the recursive definition to find a to the 100. Don't actually determine the value. So to find a to the 100, we're just going to have to keep subtracting -4, -4, -4 from each term 100 times. And that's going to get us at a to the 100. Again, if you go back to what I believe is lesson 3, but it's possibly lesson 4, you can see how to do it in an Excel spreadsheet, which will save you a lot of time. Let's go on to the next question. Problem 4. A geometric sequence starts with 80, 40, ... Write a recursive function for this sequence using function notation. Okay, well, to get from 80 to 40, I know I multiplied by 1/2. So 80 times 1/2 will give me 40. So to write a recursive definition, I'm going to say, well, my first term I know is 80, and every term after that is going to be the term before times 1/2. And we're done. Use your definition to make a table of values for the first 6 terms. So this time it specifically asks for a table of values. So let's go. We're going to have a to the 1, a to the 2, a of 3, a of 4, a of 5, and a of 6. Our first term is 80. We multiply by 1/2 is going to be 40, 20, 10, 5, and 2.5. Explain how to use the recursive definition to find g to the 100. Don't actually determine the value. Yep, so we're going to keep multiplying the one before by 1/2 over and over and over again until we get to g to the 100th term, and then we're going to be done. So this is how we're going to use this function. We're just going to have to keep repeating it to identify what g of 100 is, or the 100th term of the sequence. Problem number 5. Match each recursive function definition with one of the sequences. So let's see what's happening here. Now, like I did in the last lesson, what I like to do is I like to identify geo or not geo. Now, they're all multiplication, so they're all geometric. But what I do notice specifically about this one right here is that it's multiplied by 1/2, which means this one over here is going to get smaller. The only sequence I see is getting smaller is this one. So without any extra work, I can match them together. Now we've got to identify the difference between this and this. Here, it's 2 times p n minus 1, which means we're going to multiply each previous term by 2 to get our answer. Looking quickly at our answers, well, 4 times 2 is 8, 8 times 2 is 16. There we go, we figured it out. Now, without doing any mathematics, we were able to identify the correct answer for each question. If you want to take a second and see how you plug in the numbers here to get the numbers there, go ahead and do that on your own. If you don't know how to do it on your own, again, in the last video, there was an example just like this, so I recommend you going back and checking it out. Problem number 6. For each sequence, decide whether it could be arithmetic, geometric, or neither. So let's get started. 25 to 5 to 1. Well, to get from 25 to 5, we could subtract 20 or divide it by 5. But to get from 5 to 1, we have to divide by 5, which makes this geo. Let's check out this one. 25 to 19, that would be minus 6. 19 minus 6 is 13. Okay, which makes it arithmetic. Arth. 4 to 9 to 16. 4 to 9 is plus 5. Nope, that's not arithmetic. 4 times anything gets you 9. It's some fraction, but that fraction multiplied by 9 is not going to get you 16. 4 squared, 3 squared, 16 squared. We didn't do that yet, so we're going to say neither. I'm just going to write none in this case. 50 to 60 to 70, well, that's plus 10 for each one, which makes this an arithmetic sequence. 1/2 to 3 to 18. Well, adding, it would be add 2.5, but then you have to add 15, so it can't be arithmetic. So 1/2 times 6 gets you 3. 3 times 6 gets you 18. That makes it geo. And we're done. For each sequence that is neither arithmetic or geometric, how could you change a single number to make it an arithmetic sequence or a geometric sequence? Well, if I took this and I said 4, 8, 16, then we're multiplying it by 2 each time, and it turns it to a geometric sequence. If I said 4, 9, and I added 5, I would change a 16 to 9 plus 5 is 14, and now it's a plus 5 rule, and that turns it into an arithmetic sequence. It's pretty easy to do in this question because you only have 3 terms. So you just have to find a relationship between the 2 of them and make the third one fit. But yep, that's what you would do in order to switch it to a geometric sequence and then to an arithmetic sequence. All right, so if you have any questions, please put them in the comments below. Otherwise, make sure to like and subscribe, and I will see you in the next video.